Students, today we are going to solve the numerical problems in the chapter array of things. Exercise problem number 1. An object of height 4 cm is placed at 6 cm in front of a concave mirror of radius of curvature 24 cm. Find the position, height, magnification and nature of the image. So you all very well know that for a concave mirror, the reflecting surface is facing towards the left. That is, the focus is located on the left side of the concave mirror. So when you measure the focal length, you are supposed to go from the pole to the focus towards the left hand side. That is opposite to the direction of the light. So F is negative. The focal length of a concave mirror is negative. The radius of curvature of this concave mirror is also negative. Okay, now what are all the given quantities? The height of the object is 4 cm. So height of the object h is equal to 4 cm. And it is placed at an object distance of 6 cm. So always object is placed on the left side of the reflecting surface. So object distance is always negative by the sign convention. So I will write u, the object distance is equal to minus 6 cm. Okay, height of the object is positive because it is kept above the principal axis. And the object distance is towards the left side of the mirror, so it is negative by sign convention. Then the radius of curvature is 24 cm. So radius of curvature r, so it is measured against the light, therefore it is minus 24 cm. So F is equal to what? R by 2. This should be minus 12 cm. Okay, students. So I have applied the sign conventions. So find the position. So what is asked here? Position means image distance. So the image distance gives the position of the image. Then the height of the image. So height h dash of the image we have to find out. Then the magnification m. Okay, magnification we have to determine. And finally the nature of the image. Okay, so we will do step by step. So what are all the given quantities? You see here, focal length is given, object distance is given. So from this image distance can be determined. So what is the formula from mirror? So from mirror equation, I will write the mirror equation here. Okay, so the mirror equation relates the object distance u, image distance v and the focal length. So 1 by f is equal to 1 by u plus 1 by v. Okay, so students, f is given and u is given. We can find v. So I will rewrite the equation. 1 by v is now equal to 1 by f minus 1 by u. Okay, minus 1 by u. So I will substitute for f is equal to minus 12 and u equal to minus 6. So 1 by v is now equal to 1 divided by, what is f here is minus 12. So this is a minus 12 and minus of 1 divided by u equal to minus 6. So this is a minus 6. So minus of minus will become plus. So this is also now equal to 1 by 6 minus 1 by 12. So the LCM will be 12. So this is now equal to, this is a 2 minus 1 divided by 12. So this is equal to 2 minus 1 is 1, 1 by 12. So 1 by v is equal to 1 by 12. Therefore what should be the image distance? V must be equal to plus 12 centimeter. Why I have specifically written plus here? This is by the sign convention. When will be the distance positive? When the distance is measured from the pole to the right side, okay, on the other side of the mirror, that is along the direction of light. So the image is formed inside the mirror, is it not? So when the image is formed inside the mirror, the image distance will be positive. So first one, we have found the position of the image. This is the position of the image. Okay, now what is the next magnification? Then h dash, okay, h dash. Now magnification of the mirror. See, magnification m is equal to, either we can use h dash by h, or this is also equal to minus v by u. Understand? Minus v by u. So magnification is asked here. I will write this expression minus v by u. So magnification m is now equal to minus of v is equal to plus 12. So this is a 12 divided by u is equal to minus 6. So m is now equal to this minus, and the minus will become plus. So that 12 by 6. So this is equal to 12 by 6. That is equal to 2. Okay. So 2 means what it is? Plus 2. Plus 2. So magnification is plus 2. So the image is 2 times magnified or bigger than the object. So this is an enlarged image. Okay. This is enlarged because it is twice the size of the object. So I have written here as enlarged image. Once again, h dash can be found from this same equation, is it not? Because h is given, m is 2, so h dash can be found. So once again, m is now equal to h dash by h, and this implies what? H dash is equal to m into h. Therefore, what is the size of the or height of the image? H dash is now equal to m. M is 2. So this is 2 into h. That is, height of the object is 4. So this is equal to 8 centimeter. Okay. So we have found the size or height of the image is 8 centimeter. So object size is 4 centimeter, image size is 8 centimeter. So magnification is 2. So we have found all these quantities which are asked. And what is the nature of the image is being asked. Okay. So the nature of the image, what is this nature of the image on the other side of the mirror? It is virtual image. Is it not? So virtual, we can write like this: image, okay, image is virtual, then it is erect, is it not? Because we have got the height of the image is plus 8. It is above the principal axis. So virtual, it must be erect and enlarged. Okay, and enlarged. So this is the way you have to do the problem. In any problem, first what is the given quantities you write clearly. Particularly in ray optics, we are supposed to follow the sign conventions, is it not? So the distance will be given only as a number. There minus, plus and all will not be specified. So we must better draw one schematic diagram like this and understand that for a concave mirror, the focal length is negative because focus is on the left side. Then center of curvature is also on the left side. Therefore, radius of curvature is negative. Okay, only the object distance is positive here. Then depending upon the image, if virtual and erect image is formed means then the height of the image is positive. Okay, I hope you must have understood well. Fine.